All right, we're heading into a topic that is not covered in your textbook. And so take out this notes packet for today. And we are going to start dealing with two specific transformations. And today's topic is called translations. So first, let's get your essential question taken care of. How do I graph and, oops, I can't even spell this morning. How do I graph and find the coordinates of a translation? So first, I guess we had better conquer some of what this terminology means. Transformation, to transform, or if you've ever seen those movies about the Transformers or anything, transformation has to do with something changing, okay? And in math, we're usually talking about either a point or we're talking about some sort of shape or figure. So it is described as a change in position, or it could be a change in the orientation, meaning is it facing the same way? And say of a figure. We could also talk about a point as well, although the orientation thing wouldn't really apply there. So this covers many different types of changes in position. We can have rotations, reflections, dilations. Today, though, we're going to start with what's called a translation. So first of all, what a translation is it's a specific kind of transformation. And it travels along some sort of line. Along a line. We often just call this way, a slide. We're going to slide it somewhere else to a new position. You'll hear us refer to the pre-image and the post-image. Some textbooks use a little different terminology, but the pre-image is the before and the post-image is the after. There are two ways that we can describe how to move. Sometimes we'll use words. And when we use words, we will say something like move, for example, 5 units left and 3 units down. Okay, so then what you would do is take every point that you can find and move it 5 units left, 3 units down, and then draw your new figure or your new shape. Sometimes, rather than words, we can use an algebraic way to express the transformation. So if I'm specifically talking about something like this, move 5 units left, x is the coordinate that travels horizontally. And moving to the left, we would think of subtracting or of a negative number. You're traveling to the left. 3 units down, that's a vertical position movement, and y is the coordinate and the axis that deals with vertical position, and 3 units down would be -3 or thinking -3. So sometimes you'll see it written shorthand like this algebraically. Sometimes we'll use it in words, and now sometimes we'll do it both ways. So take a look at this. In words, this means 7 units to the left. Algebraically, we would write it this way. This is a transformation where you take your x coordinates and subtract 7, which means go to the left 7. The y value, nothing is changing here, so my y values are going to stay the same. So start marking each one of these points, because what we're going to do now is move each one of these 7 units to the left. 1, 2, 3, 4, 5, 6, 7. There's the first one. This one, 1, 2, 3, 4, 5, 6, 7. This guy, 1, 2, 3, 4, 5, 6, 7. And this one will be down here. And then these two guys, 1, 2, 3, 4, 5, 6, 7, and there. And simply redraw your figure. Play connect the dots. There you go. Sometimes it might be helpful, depending on the visual that you're given, to kind of shade them in so you can see the difference, and you kind of go from there. All right. It's a slide 7 units to the left. Now, what I want you to notice is that the position has changed. I'm in a new location with my new transform shape. The size, however, stayed the same. So sometimes in math terms, we call that congruent and use that symbol. And notice something else. My orientation, meaning the way that I am positioned, how I am facing, so to speak, my orientation stayed the same. I didn't turn it or alter it so it's facing a different way. It looks exactly the same. I just slid it way over here. All right, let's try a few more. Turn the page. Algebraically, this says take x and subtract 2. That means move 2 units to the left. And y plus 3 means you move 3 units up. On this one, kind of the main points here, or coordinates, I've got 1, 2, 3, 4, 5. So I don't want to lose what I have to do here. 2 units to the left, 1, 2, 3 units up. So this point goes here. I'm going to do this top one next. 2 units left, 3 units up. And if it helps you to connect right away so you can kind of see what you've drawn so far, 2 to the left, 3 up. Now I'm coming to this one. 2 to the left, 1, 2, 3 up. Last one, 2 to the left, 1, 2, 3 up. And there it is. Okay, cool. Now, honestly, because we're math nerds, typically we will start to label some of these points, and then we have to distinguish between what was the new one, the pre-image, and what was the post. In fact, on this one, we could label this the pre-image and then call this the post-image to say this was the before and this was the after. Mathematically, rather than write pre and post image all over the graph, honestly, what we do is just usually label each of the points with a value here. Also, I want you right now, kind of typo there, I want you to change this coordinate of C. I want the y coordinate to be positive 2. All right, here's the first point. A is -2, 1, 2, 3, 4, 5. -2, 5. That's A. Label it. B is 0, 1. Here's B. C is 1, 2, positive 3, up 2. See, if I had left C with a y coordinate of -2, that would hardly look like a triangle anymore. So my bad. All right, connect this so that we can see what our original triangle looks like. Now we are going to transform this with a translation. Every x coordinate is going to be added 1. That means you're going to move to the right 1 unit. My y coordinate, I'm going to subtract 4, which means you're going to go down 4 with every point. Okay, so go to the right 1, down 4. Here's A. Go to the right 1, 1, 2, 3, 4. Ooh, it's right there. Now, how am I going to label this? Because I can't really call this just A again. It's my transformed A. So we're going to label this as A with a little accent mark or apostrophe here. And on this line, I'm going to do that right there. A apostrophe. Now, what we call this in math is A prime. Let's do point B. I'm starting here. I have to go to the right 1, down 4. Right 1, 1, 2, 3, 4. This is B prime. And C, go to the right 1, 1, 2, 3, 4. Okay, here's your new transformed triangle. I got to make sure that looks right. To the right 1, 1, 2, 3, 4. Okay, right 1, down 2, 3, 4. All right, there we go. Looked a little weird at first. Okay, if you want to, if you have different colors or you just want to shade one of them in so you can distinguish between the two. This is the pre-image. This is the post-image. A prime, B prime, C prime. Now, what you can do is look at your graph now and tell me the coordinates of our new points for A, B, and C. This appears, let me see, -1, 1. -1, 1. No. Does that make sense? Yeah, because take a look. I'm saying add 1 to the x value. Look at my original x value for A. If you add 1 to that, you get -1. I'm saying subtract 4 from the y value. 5 minus 4 is 1. There you go. So you can either read your coordinates right off the graph, or you can do the math operations as described in the algebraic method of describing this translation. This becomes +1, -3 for B prime. +1, -3. The graph works. If I add 1 to x, but subtract 4, that works. You have a lot of ways to check your work. And from 3 +2, these coordinates should be add 1, subtract 4. I should be at 4, -2 for C prime. 4, -2. Bingo. There you go. All right, let's do a couple of other ones that look a little bit differently. Here you're getting the graph of your original triangle LMN. This is the pre-image. Here's the translation, the post-image. Can you tell me what we did to get from L to L prime, M to M prime, N to N prime? Really, there's no faster way than just basically counting. So here we go. Here's L. Here's L prime. It looks like I went 1, 2, 3, 4, 5, 6, 7 to the right. So you could say 7 right or right 7. And then vertically, I went down 1, 2, 3, 4, 5, 6, 7, 8. Down 8. 8 down or down 8. Algebraically, it would look like this. My x coordinates are going to increase by 7. I add 7 to each. My y values will decrease or go down by a value of 8. Done. No, now here's the challenge on this guy. And actually, yours look a little differently because I had a typo. So I need you to add this on your notes because I neglected to write that in. So write T for a transformation. My x values will be increased by 3. My y values will be decreased by 6. So in other words, you are going to go to the right 3 and you are going to go down 6. That's what the transformation said. Now, here's what I want you to do. I accidentally wrote Q prime, R prime, and S prime here. So you can leave those there, and let's write those in. Right now, if you look at your graph, Q prime is at this coordinate, -1, -9. R prime is at a +2, -1. And S prime is at 8, -4. Now, this is the post image. I want to go backwards and figure out where was my original pre-image? Where did I start? My Q, my original Q, and let's write these over here. My original Q point was somewhere over here because then I added 3 and went down 6, and this is where I landed. So can you go backwards? In other words, instead of going right 3, go to the left 3 and go up 6. 1, 2, 3, 4, 5, 6. I think this is where Q had to start, because if I started here and I went to the right 3, down 1, 2, 3, 4, 5, 6. Okay, so this one is working backwards. My original starting point for Q looks to be at -4, -3. And if I take this Q value and I add 3 to -4, I'd get -1. Down 6, subtract 6 from here, I'd be at -9. That works. Let's do the same thing with R. Here's where I landed at R prime. Work backwards by going to the left 3, up 2, 3, 4, 5, 6, up 6. Looks like I'm right there. This is where R started in the pre-image. It looks like my coordinates are at -1, 5. If I started here and I went to the right 3, in other words, add 3, I'd get 2. Subtract 6, down 6 from +5, I get -1. Yes. Last but not least, let's find out where S began. My S prime was at 8, -4. All right, we're going to go to the left 3 and up 2, 3, 4, 5, 6. Here's S. It looks like these coordinates are at 5, 2. Does that make sense? If I started here and I went to the right 3, that means add 3 to 5. That's 8. Down 6 means subtract 6 from +2. 2 minus 6 is -4. There we go. Here is the pre-image. Right there. Pre-post. We're all about sliding today. All right, your assignment is posted in Schoology and it's certain problems in the packet. Good luck and may the force be with you.